So far as we've been talking about probability and sample spaces, we've been dealing with pretty simple events, kind of one thing at a time, really easy to describe what happens, really easy to understand how the probability experiment is conducted and what the results could possibly be. Well, now in 10.4, and there aren't any notes for this, so you'll notice this is actually your assignment. We're going to go and do several problems from your assignment. What we're talking about is sample spaces and probabilities for compound events. So I'm going to underline compound events right there, and I'm also going to underline it as we go through and read the instructions. So here's what it says. The tree diagram to the right shows all the different outcomes for a team playing 3 games. Complete the list of outcomes and use the sample space to find the probabilities for the compound event. So there are a couple things that we definitely want to notice. We need to know what a compound event is, and we need to know what a tree diagram is. Well, if we take a look over here, this is the diagram off to the side. I mean, it's pretty easy to see why they called this a tree diagram. So what we have here is we've got some branches right here. So this is game number 1 for this team that's playing in this 3-game tournament. So here's game number 1, here's game number 2, and here's game number 3. You can kind of see why we call these compound events, because they're playing a game, winning or losing, playing another game, winning or losing, and then playing a third game and winning or losing. So that's more complex than just a plain old simple event. You know, flipping a coin, rolling a die, pulling a marble out of a hat, or something like that. So this compound event is kind of made up of 3 simple events put together, if you wanted to think of it that way. So here's our tree diagram. So in game number 1, there are 2 possible outcomes. And if we stopped right there and just said, hey, what are the outcomes if we play one game? Well, it's either win or it's lose. Well, in this case, we're playing another game. So if we win the first one, then we have to branch off that and give the possibilities for the second game. Well, if they win the first one, they could win the second one, or they could lose the second one. If they lose the first one, they could win the second one or lose the second one. And then we've got this third game. And you'll notice that even with 2 outcomes for each game, either win or lose, notice how many outcomes we have here in the sample space. And let's take a look. We've got these branches, we've got these arrows, and let's take a look at this outcome right here. That WWW, and that comes in handy when we're doing tree diagrams, is to have some way to kind of shorten this because there's so many outcomes. That WWW stands for win, 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 and in that order. So it makes a difference what order they come in. Now win, 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 they won them all, so I mean the order we move those around doesn't really make a difference on this one, but it will in just a second, and you'll see what we're talking about. So this literally means won the first one, won the second one, won the third one. Well, let's write down this one here, and let's follow the branches on the tree diagram in order to figure it out. So win the first one, win the second one, and then down here we lose the second one. So we're going to do win, win, and loss. And that's kind of our key for figuring out what this sample space is going to look like and what each one of those means. So let's follow this one right here. Win the first one, lose the second one, follow up here, and then win. So this is a win, a loss, and a win. Let's do this one here, win, loss, and loss. So WLL. Okay, now you'll notice that here we start with a loss. So we're going to do a loss. Unlike all of these, they started with a W. All of these down here, they're going to start with an L. So lost the first one, then won, and then won again. So LWW. This one would be loss, win, and then loss. So LWL. And then loss, loss, win. Loss, loss, win, and then here's the last one. And you'll notice that we've kind of come full circle here. This top one was win, 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 and this one is loss, loss, loss. So we've got an L, an L, and an L. And then we can answer some of these questions over here. So it says, what is the total number of outcomes? So when this team plays in this tournament, there are actually 8 different outcomes. You can count them, 1, 2, 3, 4, 5, 6, 7, 8. There are 4 up here that start with a win in the first game and 4 down here that start with a loss in the first game. You'll notice that we've got a WW that comes second and a WW that comes right here, then a WL, a WL, an LW, an LW, and then an LL. So you can kind of see some symmetry, some nice things that kind of line up and some patterns that develop here. So there are 8 outcomes altogether, 8 outcomes in the sample space. And then it says, what's the probability of all wins? Now, we'll assume that each one of these are equally likely, kind of like flipping a coin. So this would be all wins would be 1 out of all of those 8 events. Probability of exactly 2 wins. So let's go through here and take a look at this. Exactly 2 wins. Well, that's not exactly 2 wins. So there's exactly 2 right here. So I'm just going to put a 2 off to the side right here. There's exactly 2 right here. Are there any others with exactly 2 wins? There's one right there, 2 wins there. None of the other ones have exactly 2 wins. So it's these 3 out of the 8 altogether. So this is going to be the probability here is 3/8. Okay, so that's how we answer each one of those. I'm going to leave a couple of these for you to do, especially since we filled out the tree diagram. We're going to take a look at this next one. This one's a little bit more complicated. And again, I'm not going to do every single one of these, but we're going to look at enough that you can figure this out. So it says the tree diagram to the right shows all the different outcomes for the compound event of flipping a coin, spinning a spinner with 5 sections, red, orange, yellow, green, and blue, and then flipping another coin. So here's the compound event. This is why this isn't a simple event. We're going to flip a coin, record the results, either head or tails. Then we're going to spin a spinner that has 5 sections, red, orange, yellow, green, and blue. And then we're going to flip another coin. So let's say we get a head and a red, and then we flip a coin and we get a head. We're going to mark that down as HRH, and that first one's there for you. The next one would be if we get a head, a red, and then we get a tail. So that's going to be H, R, and T. So let's follow the next one. Okay, this is going to be a head here, and then an orange, and then a head. So that would be, whoops, getting ahead of myself here, H, O, and H. This would be H, O, and T. Next one, so we've got heads on the first coin flip, yellow, and then a head. So this is going to be H, Y, H, and then it's going to be H, Y, T. Now, if you take a look here, I think you'll notice something. H, R, H, H, R, T, H, O, H, H, O, T, H, Y, H, H, Y, T. So this next one is going to be H, G, H. Well, you can tell from the pattern, you'll notice that you'll look and see what happens here. On each one of these, we've got the last one as heads, then tails, heads, then tails, heads, then tails. So this next one is going to be H, G, and T. And then down here, we're going to have an H, a blue, and then a head, and a blue, and then a tail. And then I think you can fill these in right here. And we've kind of done you a favor. You'll notice that we figured this out. Let's see, there are 2, 4, 6, 8, 10. So there are 10 outcomes in this part of the sample space. And I think you'll notice because we've got red, orange, yellow, green, blue, head, tail, it looks just like the one above. The same thing is going to happen down here, but they're going to start with tails. So go ahead and fill those in. But if there are 10 up here and 10 up here, that means there are going to be 20 outcomes altogether. And then it says find the probability that we get a red. So what you're going to have to do is you're going to have to go through and you're going to have to count all the ones that turn up to be red. So there's a red one there and a red one there, and you'll notice that's the only specification on this event. It just has to, the spinner has to turn out to be red. So we've got 2 of them there, and then you want to count up how many there are down here, and you'll put that out of 20. Okay, same thing here with exactly 1 head, or at least 2 heads or something like that. Okay, so that's the idea with 6 through 10. I am going to go ahead and finish this one because you'll notice right here, if we do tail, red, and head, and tail, red, and tail, the rest of these are all going to have orange, yellow, green, and blue. So none of these are going to have red in them. So let's go through and count. There's a red, there's a red. None of these are red, and then those are the only other 2 red ones. So that means there's going to be 4 altogether. So we're going to put 4 out of 20. And then we're going to simplify that. We always want to simplify those if they're our final answer. So 4 goes in here once, and 4 goes in there 5 times. So we end up with 1/5. Now, you can finish the rest of these, but I want you to think about this answer is 1/5. Does that kind of ring a bell? Is there anything else in here that would clue you into the fact that the answer on this one for the probability of getting a red when you spin this is going to end up being 1/5, regardless of what we have as a heads or a tails on the first coin or heads or tails on the second coin? Okay, let's talk about this one right here. Again, I'm not going to do this entire thing, but I am going to do enough that you can kind of get a feeling for what goes on here and then answer the question. It says class elections are being held at Bingham High School for the upcoming school year. Ben and Kylie are running for class president. Mike, Emma, and Adeline are running for vice president. It says create a tree diagram and determine the total number of possible outcomes. So we're going to keep track of the president. We'll say that that's on the ballot first, and then we're going to keep track of the vice president. Now what we're going to do here is we're going to say, okay, we've got Ben and Kylie. So we could choose Ben or we could choose Kylie. Now one thing that I'd recommend when you're doing a tree diagram, they take up more space than you would think. You wouldn't think that in doing this problem that was described with flipping coins and spinning spinners that we take up that much space. And you wouldn't think that keeping track of the outcomes for 3 games in a three win-loss in a 3-game tournament would turn out like this. They end up taking up a lot of space, so kind of give yourself a little bit of extra space. This one's not too bad. So we can choose Ben for president, and then how many options are there for vice president? Well, we could choose Mike, Emma, or Adeline. So I'm going to do Mike, Emma, Adeline. And then we can do the same thing down here. Well, if we choose Kylie as president, you'll notice that there's some patterns here to the way that we did up above, Mike, Emma, or Adeline. So that means our outcomes are Ben and Mike. This one would be Ben and Emily, or Emma. This one's going to be Ben and Adeline. This one's going to be Kylie and Mike. This one's going to be Kylie and Emma. And this one's going to be Kylie and Adeline. So now we know how many outcomes there are, so we're going to call that, let's see, we've got 3 up here, yep, we're good there, and 3 there, so that's going to be 6 altogether. So 6 outcomes altogether. And then it says, what is the probability that the president and the vice president are girls? The president and vice president are girls. So there are 6 outcomes here. We'll assume that they're all equally likely. We don't have anything to believe otherwise. We need both of them, the president and the vice president, to be girls. So as we look through here, remember that represents Ben. He's the president. There's no way we can count those. You'll want to go through and count how many here are where both the president and the vice president are girls. And then you can figure that one out. Now I'm going to flip the page over. I'm going to have you notice that on this problem right here, it's got some vanilla ice cream that you choose, then some fudge toppings some toppings that you choose, and then some sprinkles. So you can choose either vanilla or strawberry. So you're going to keep track of the ice cream. So the ice cream choice is right here. Then you're going to keep track of the toppings. And then you're going to keep track of the sprinkles. Now, you've got all this space to do this, but I would really recommend that you kind of think through, gosh, how big is this going to get as I go through and do this? So this is just kind of a build up and a little bit more complicated than this one right here. Very similar, but I think you can do that and then answer the questions here. And then I want to take a look at this last one right here. I'm not going to do this. I just want to make sure we understand what's going on here because I think this is probably the most complicated one on the assignment. So this is about a pizza. Now, this is pretty amazing that when you go to a restaurant and you have lots of choices, how many different combinations of choices you can have when you put these together. But here's the deal right here. So the tree diagram has been started to determine the sample space for ordering a 1-topping pizza. Now, when we say 1 topping, what we mean is clearly there's going to be some crust and clearly there's going to be some cheese, and then you get to choose what goes on the top of that. So most things, you get the crust and the sauce and the cheese. That's a given. Okay, the options are regular or deep dish or thin. So there are 3 choices for crust. So we've got the regular crust here, we've got the deep dish or the thin crust. And then there's some choices for the cheese, mozzarella or a 3-cheese blend. So there's only 2 choices for cheese, mozzarella or 3 cheese, mozzarella or 3 cheese if we choose the deep dish. So we could almost go through and start this off like this. There's our first choice. We make our choice about the type of crust we're going to have. Then we make our choice about the 2 different types of cheeses that we can have on that crust. And then to finish this off, it says you can choose pepperoni, ham, chicken, or sausage. Pepperoni, ham, chicken, or sausage. So that means there are 4 choices here. So let's see if we can kind of diagram this, because it says finish the tree, list all the possible outcomes. So here's going to be the list of all the possible outcomes. In other words, another name for the sample space. And then they want us to say how many outcomes there are and compute some probabilities. Now, you might be able to count the lines here and you could get the answer to number 16, but I don't think that's the point here. So let's take a look here. We're going to choose regular crust, mozzarella, and pepperoni. So we're going to have RMP. So that's the first one. Regular crust, mozzarella, then we're going to choose ham. So that's going to be RMH, and we know what that abbreviation would stand for. Then we're going to choose chicken, then we're going to choose sausage. So this is going to be RMC and RMS. They're all going to start the same with regular crust and mozzarella, and then the choice here is which one of those 4 meats we're going to have. And then if we look at this one right here, this is going to be regular, 3 cheese, and pepperoni, then ham, then chicken, then sausage. So this is going to be 3 cheese and then pepperoni, regular, 3 cheese, and then ham, regular, 3 cheese, and then chicken, regular, 3 cheese, and then sausage. And you'll notice that we've got a PHCS, so it goes that way every single time. So go ahead and finish all of those. Again, this isn't very hard. It's a little bit on the tedious side. It's kind of a pain in the butt, but it'll kind of get used to that, and then you'll be all set for the next section.